Good afternoon, class. Have a seat. I would like to start my go, no? Okay, so you guys had some homework? Was exercise 2C. We got up until number 5.4, no? So we must do 6 now. Okay. Yeah, and 2T. We're going to get there. So we are told that a car driving at a constant speed completes a trip in 70 kilometers in 26 minutes. How far will the car travel in 1 hour and 21 minutes if they're driving at the same speed? So speed distance time follows the triangle DST. Not so. So with the first part of the information, we're going to calculate at what speed did they travel. Can you see that? So how do you calculate speed? It will be distance over. So what's the speed? 70 distance, 70 kilometers in 26 minutes. But now we must not do kilometers per minute. We work kilometers per hour. You can work kilometers per minute, but then you have to convert that to minutes. Okay? But we normally work kilometers per hour. So your time is going to be 26 over 60. Do you see that, people? So it's going to be 70 divided by 26 over 60. Why 26 over 60? Because there are 60 minutes in 1 hour. So they're traveling at 161. Yo. It's fast, no? What is the speed limit on the 120 on the main road, no? On the highway? 161.5 kilometers, very fast. Okay? Must be a race course, it is. It's 161.5 kilometers per hour. Not so? So now, they want to know how far would it travel. So in other words, I'm going to calculate distance in the second calculation. Can you see that, people? So distance is equal to speed times. What's the speed is traveling? 161.5 times 1 hour and 21 over 60. Again, 21 minutes, I must convert that to hours. Do you guys understand? Yes. So that's going to give you, so you press answer. Why answer? It's the last answer calculated on the calculator. Multiplied by shift fraction. Why shift first? To activate the mixed fraction. Okay? 1 and 21 over 60. Gives us this is the 218 kilometers. 218,1. Okay. You guys understand? Any confusion? No? It's not hard if you're going to practice it a lot. You see, that is how maths is. It's something that needs a lot of your attention. Yeah. So, rather stick with maths. Okay. A car traveling at an average speed of 100 kilometers per hour covers a certain distance in 3 hours. Again, speed, distance, time, triangle. So D on top, H and T. Not so. A car travels at an average speed of covers a certain. So you got the speed, you got the distance. So no. We got the time. So we can work out the distance. The distance equal to speed times time. So speed is 100 kilometers for 3 hours. So it covers 300 kilometers. At what speed? So we're going to calculate speed, which is distance over time. In what speed must the car travel to cover the same distance? What is the distance? 300 divided by time, which is 2 hours and 40 over 60. Well, the sum's coming in your exam, so no mistake. It will be 300 over shift, the mixed fraction. 2 and 40 over 60. Now some of you type this thing wrong in the calculator. Alright? Then what I would rather suggest you do is, instead of breaking fraction over fraction like that, you say 300 must be divided by, we must know this is a divide line here. 300 divided by, then we put the mixed fraction in. 2 and 40 over 60. It's fine, it's fine. 1, 1, 2, comma 5. The bodies must be aligned again, okay? 1, 1, 2, comma 5 kilometers per hour. Okay, you guys understand? Number 8. Number 8 says complete the table. So yeah, we need to first check if this is a case of direct or inverse proportion. So, what is 3 times 4? 12. What's 9 times 12? Not 12. So which means to say, I'm not multiplying to get the same number all the time. So that's not inverse proportion. So, what is 4 divided by 3? Check. 4 divided by 3? 4 over 3. What's 12 divided by 9? 4 over 3. So that's an example of direct proportion. Can you see that? So this is an example of direct proportion. So we get 3 over 4 over 3 is the same as 12 over 9, which is the same as 16 over 8, which is the same as B over 50. 4 over 9, 4 over 3, 12 over 9. So, what do you say? We must calculate that this, but I'm just writing it out. So what I do is I take 4 over 3 must be equal to 16 over 8. So what do we do? Cross multiply. 4 times A is 4A. 3 times 16. How do I get A on its own? Divide by 4 both sides. So A is equal to 12. I get no 12 on it. 12. Yeah, 12 is good. Okay. Then for the B part, same story. I take B over and that one there. Or I could have taken 12 over 9. Or I could have taken 16 over 12. It doesn't matter. It's all the same thing. So 4 over 3 is equal to B over 4 over 3 is equal to B over 15. So cross multiply. So 3b is equal to 4 times 15, or 60 I could do, not 60? Yeah, 60. Divided by 3 both sides. So b is 20. You guys understand? Is this example of direct or indirect proportion?
Direct.
Direct proportion. Why? Because y over x is equal to k. Okay? As you can see here, 4 over 3 was equal to 12 over 9, which is equal to 16 over 12, which is equal to 20 over 15. Which means to say y over x is a constant. K is a constant, in other words. Okay? Let us use k as that variable. Okay? And a constant is with the c. Huh? If you plot the points, will it form a straight line or a curve? Curve. It will be a curve. Because if you look at this here, that's actually straight line. Because inverse proportion will be a curve. Absolutely. I'll show you now how it looks. It's a rough estimation here quickly. If this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5. So if you take 3 and 4, let's go 2, 4, 6, 8, 10, 12, 14, 16. Go 2, 4, 6, 8, 10, 12, 16, 18, 20. So 3 and 4, 9 and 12, 12 and 16, 15 and 20. Can you see that, people?
Yeah.
It's forming a straight line. Okay. This is by approximation. Okay.
So,
Yes? Sorry?
so me and Amara don't understand 8.1.
How can you ask me now? It's in the rest of the
So
English.
I asked.
Okay, so if you got a table like this, we must see what the relationship exists between these values. Okay? So what I said is, it's either you're going to multiply those two numbers. So 3 times 4 is 12. And 9 times 12 is 72. Okay. Is that the same value? No. If it was the same value, then this would have been an example of the inverse proportion. Okay? So since that was not the same value, I say, okay, what is 4 over 3? What's 4 over 3? What is 12 over 9? 12 divided by 9? 4 over 3. So that means to say, then this is an example of direct proportion. Okay? Can you see the same value there? This is direct proportion. So what I did was I said, okay, 3 over 4 must be equal to 12 over 9 must be equal to 16 over 12 must be equal to 20 over 15. Can you see that? So what I then said was I said 3 over 4 is equal to, sorry man, at this point I didn't have A and I didn't have B. So I put it over A and that was over B. Can you see? So I said 4 over 3 is equal to 12 over 9, which is equal to 16 over A, which is equal to B over 15. So I said 4 over 3 is equal to 16 over A. So that is all equal. So I just took this part out, so in pursuit of calculating A. Then you see 4 over 3 is equal to B over 15. Can you see that? Again, I cross multiply and then solve for B. Okay. Alright, let's look at number 9. Number 9, complete the table. Now you see here, what's 1 times 6? 6. 2 times 3? 6. Can you see that? Earlier on, I was the divisor one. Here's the one that you multiply. Can you see the difference? So what do we say? 1 times 6 is equal to 2 times 3, which is equal to, then put the A and a B here. 4 times 8, which is equal to 3 times 0,5. So, we can say 6 is equal to 4/8. So I divide by 4 both sides. So A is equal to 3/2 or 1.5 or 1.5. You will understand? Right. Then we can say that 6 is also equal to, so 6 is also equal to 0,5 B. How do I get B on its own? Divide by 0,5 both sides. It cancels, so B is equal to, what is 6 divided by 2? 3. So how can B divided by half also be 3? Huh? You put in the calculator, you'll get 12. No problem. So your A is 12, so your B is 12, and your A is 1.5. Then they ask you to plot the points and label the axis. I need 6 on the X, so it's 1, 2, 3, 4, 5, 6. So 0, 1, 2, 3, 4, 5, 6, 7, 8. It needs to go to 12, okay? But I don't have that space here, so I go 2, 4, 6, 8, 10, 12. Okay, and remember the values in the middle is the odd numbers, okay? So if X is 1, Y is 6. You see X is 1, this is your X axis. We must did graphs, no? If X is 1, Y is 6. You see that? If X is 2, Y is 3. If X is 4, Y is 1.5. No. This is 1.5. If X is 12, okay, it goes further down here. If X is 12, it's actually this one I had to change, not the Y. The X had to change. So let's go again. Then make this 2, 4, 6, 8, 10, 12. I'll keep this 1, 2, 3, 4, 5, 6. Okay. So if X is 1, Y is 6. You'll see the effect better on the graph. Okay. If X is 2, Y is 3. If X is 4, Y is 1.5, this is 1.5. If X is 12, Y is 0,5. If 1 is then 0,5. It asks us to connect this. Is this a straight line or a curve? A curve. You see that, people? Join the point. Is the graph an example of direct or indirect? Indirect or inverse proportion. Right, 2D. So 2D, we are told that car dealer is selling Hondas, Toyotas and Kias in the ratio 4:7:2. Honda, Toyota, Kia. This part is easier, no?
Yes.
So Honda is 4, Toyota is 7 and the Kia is 2 in that ratio. So under 20 years, you're getting ahead of me now. So the 28 Toyotas are sold last month. Calculate how many cars are sold in total. So we're going to bind this here. We then say 28 divided by 7, which is 4 per. So So on this, how many on this you selling? 4 times 4, which is 16. Here, 2 times 4, which is 8. So your total number, 16 plus 28 plus 8 is 50. So let's look at number 2. 1,800 is divided between John, Johan, Pierre, and Mark. Johan gets 3 times as much as Mark, who gets 2 times as much as Pierre. So who gets the least? So we let him get 1 or X, okay? So he did Pierre, P-I-R-R-E equal X. So if he gets X, then Mark gets 2X and Johan gets 6X. So it's 6 is to 1 is to 2. Not so? Yes.
So if you do it like that, no, but you don't say it, PA, 6, PX, no?
Yeah, you brought the X in. You lose 1 more. Okay. You must tell the people who's your X. Not so?
No, sir.
You don't have to tell them. You just gonna let him like walk around and be lost and stuff like that. Nah, you're not like an X. I'm joking, eh? Alright, so what do we do here? You say 6 plus 1 plus 2 gives you 9. So it's 1,800 divided by 9, which is 200 per unit. So Johan gets, so what's the question? How much money does Johan get? So it's 6 times 200, which is 1,200. So Johan gets 1,200. That's what they wanted. But normally we go and work it out, all of it, no? We just that kind of girls and guys. The 2 times 200, which is 1. But that's the value they're looking for. Not so?
So, and you stop this time?
You were stopped here. Full marks. Right. Worksheet 2D. 4 bread rolls cost 7 rand. So 4 cost 7 rand. So 7, so this is now number 3. So it will be 7 over 4. So it's going to give us. So 7 divided by 4 gives us 1 rand and 75 cents per roll. Per roll, no? That is that time. Now we're paying 10 rand a roll. At Nando's. Yes. 10 rand a roll here. Yes, that's why when I go there I take my own rolls. Right. So people listen, relax. The people we're going to talk about Nando's now. Okay? You want to know how much? Well, 2 dozen. People, how much is a dozen? 12. 2 dozen? You see that is now because I want Nando's. You see? 2 dozen. So listen. The roll costs 175 cents. So it's 24 times 175 cents. Going to give us 42. That 42 rand. Yeah, no, that's a half a dozen. 6 is half a dozen.
Yes, sir, I get that, but then I'm thinking of this on the side, 12 times 1.
Something wrong with you? And something wrong with you, okay? Everybody wants something to be something wrong with you. People 2D, number 4. It takes Dion 3 hours to paint a wall that is 9 meters long and 15, 5 meters high. How many meters square can Dion paint in 1 hour? So firstly, I need to work out how many meters square this is. Not so. So how do you work out the square meterage? So the area is equal to length times. The length is 9, the breadth is 5, which gives you 45 meters square. So the area or the meterage of that Molly's in his painting is 45 meters square. He covers 45 meters in 3 hours. So that means to say it's 45 meters square divided by 3 hours. He covers 15 meters square per hour. How much can he paint in 1 hour? 15 meters. Simple. Easy mathematics. Okay. People don't try and complicate these things, okay? It looks good. A lot of words now. Yes.
No, so why does it do pure math? I try to agree to that.
Huh?
Why does it?
Yes, I want all of you to do pure math. What do you say, my girl? You don't want to go to grade 10. If you want to go to grade 10, okay? No. Why? You're giving up the fight. Are you going to become a doctor with maths? Are you going to become a maths teacher? You need maths, man.
No one likes math.
Jessica, how much Anna sleep at night? How much Anna feel? I feel cheated on now. You hurt my feelings, no? Right, let's rather stick to the 2D, yeah? Number 5, at the local supermarket, 0.5 kilograms or half a kilogram of all brand flakes cost 22 Rand 99. That's it back in the day. Eh? While a 750 gram box costs 35 Rand 99. Which pie is the most expensive? So what I need to do is I need to work out the rands per gram. Not so. So, I need to first get it both in 1 gram. So we're going to say 22 Rand 99 divided by 0.5. But this is kilograms, no? So that means to say that 22.99 divided by 0.5 is 45 Rand 99. So it's basically 46 Rand per kilogram. That's rands and this is kilograms. Right. So that is the first case, the first scenario. Here.
So for 22 Rand 99, can't you just write 23 Rand?
You could? Yeah. But use what is given. Because normally we work to 2 decimal places anyway. So if it's given to 2 decimal places, we use it as it is. Okay. Then in the second scenario, remember that we're comparing to kilograms. So I must convert that value to kilograms. Otherwise I had to convert that 0.5 to grams. It must be of the same unit. Otherwise you can't do comparison. Okay, so what we have in the second scenario, you got 35 Rand and 99 cents divided by how many kilos is that? 0.75 kilograms. Not so? So that's going to give you 35.99 over 0.75. It's going to give you 47 Rand and 99 cents. 47 Rand and 99 cents. So which one is the more expensive buy? The bigger box is actually more expensive. Yeah. But the bigger box is more expensive if you do the comparison. Okay. Sorry? Look at number 6. Johannesburg is 1,420 kilometers from Cape Town. So you go Johannesburg to Cape Town. I don't know, let's check. Johannesburg Airport. $1,396 kilometers. So yes, 1,420 is about right. Yes. Okay. So if you drive, listen, if you're driving 120 kilometers at the constant speed of 120 kilometers per hour, which is not possible, no? You must stop and all of those things. So you're driving at that speed, so it's 1,420 kilometers at the speed of 100. Let's say he's traveling at 100 kilometers per hour. You'll take him 14 hours. Okay, to drive. But of course, you must you must take breaks and. Yeah, that's not right. You must break it. Okay. So, Johannesburg is 1,400 kilometers from Cape Town. Determine the average driving speed of Christo if he completes a journey in 13 and a half hours. So, the distance, speed time. Okay? They want to know is the average driving speed. So S is equal to D over T. So it's 1,420 divided by 13 and a half hours. 1,420 divided by 13 and a half. It's going to give us 105.119 kilometers per hour. Okay? Yes? Right, so listen. I'll give you another chance to complete these sums. There's a lot of sums I gave you, no? Okay, so in our next lesson we will conclude this worksheet, okay? And then we'll start our new topic on Monday. Sure. Okay. Yeah, you can go to the toilet, yes? So we'll stop here today, okay?